Hello, ladies and gentlemen. Welcome to Calculus, Math 31, Chapter 1, Lesson 2, The Limits of a Function, Part 1. Now, here we'll explain the concept of a limit. Now, limits are fundamental to the study of calculus. In fact, limits are what set calculus apart from other branches of mathematics. Now, we've already seen how limits are essential to finding slopes of a tangent line. Later, we will use limits to compute velocities and other rates of change. All right. Now, to do this, we need to take a look at specific methods for calculating limits of a function. This means that we will be investigating the behavior of a function as we approach a specific value of x. Now, here, let's use numerical approximation to find the limit as x goes to 3 of x minus 3 divided by x squared minus 4x plus 3. Now, notice the numerical approximation. We can simplify this. This is the limit as x goes to 3 of x minus 3. Now, x squared minus 4x plus 3, you can factor. That becomes x minus 3 times x minus 1. Now, here, x minus 3 cancels out in the numerator and the denominator. So this is the limit as x goes to 3 of 1 over x minus 1, sorry. As long as x does not equal minus 3. So you can't cram that in there. X cannot equal 3. Sorry. Now note that the expression is not defined at x equals 3 because the x minus 3 cancels out. So x minus 3 can't equal 0, x can't equal 3. This does not matter. Finding the limit only requires finding the trend as we approach 3 from both sides. All right? So, let's do some calculations. X is 2.5, 2.9. Well, when x is 2.5, this is, remember, it's 1 over 2.5 minus 1, which is 1 over 1.5, which is 0.6 repeating, which is 2/3 or 0.6 repeating. Right? Now when x is 2.9, I got 0.5263. Now when x is 2.99, I got 0.5025. And when x is 2.999, I get 0.5003. Now, I'm going to pause the recording, and I want you guys, sorry, not too many zeros there, to do the table for x is greater than 3. All right? So remember, this is 1 over x minus 1. So 3.5 minus 1 is 1 over 2.5. Actually, no, I'm going to... Welcome back. So when I plug the numbers in, and this should be 3.001, one too many zeros, you'll notice we're getting 0.4998, getting closer and closer to 5. So, you notice a pattern here. As x approaches 3, f of x approaches 0.5. So, the limit as x approaches 3 of x minus 3 divided by x squared minus 4x plus 3 is 0.5. All right? Please tell me you did that math. Now, we write the limit x approaches a if f of x equals L, and say the limit of f of x as x approaches a equals L. If we can make the values of f of x as close to L as we like by taking x sufficiently close to a, but not equal to a. All right? And that's kind of picky and important, but not equal to a. All right? So, let's do some examples. So let's do number 2. Let's use simple substitution to find the limit as x approaches 5 of x squared plus 2x minus 3. Now, here, this question is very simple because the function is a polynomial and it's defined for all values of x. If you look at the domain of this, x is all real, so this should work for x equals 5. There's no asymptotes, there's no holes. So what's the value here? When we plug in the numbers, this is limit as x approaches 5 of 5 squared plus 2 times 5 minus 3. It's 25 plus 10, 35, 32. Yes, I'm skipping some steps, but this is calculus. You should be able to do some of the simpler steps in your head. Okay? Now, that's too easy. Okay. Algebraic methods for finding limits of more difficult functions rely on the properties of limits. Now, the properties of limits are something you're supposed to know. And here's a list of them. First one, sorry, the limit as x approaches a of some constant c is c. All right. Now, the limit of x approaches a of x will equal a. The limit of x as x approaches a of f of x plus g of x is the limit of x approaching a of f of x plus the limit of x approaching a of g of x. I apologize, there's a typo here. This is supposed to be minus limit of f of x minus g, sorry, limit of x minus a of f of x plus g of minus g of x is limit of x minus a of f of x minus limit of g of x. And number 5, you're multiplying by a constant. You can factor the constant out. Yes, we will do a bunch of examples. 6, multiplying the two functions. The limit of your multiply divide. It's the same thing. Note, g of x, your denominator cannot equal 0, or bad things happen. Number 8, limit of x approaches a bracket f of x close bracket to the nth power is bracket limit of x minus x approaches a of f of x close bracket to the nth power if n is a positive integer. And same thing with the root if the root exists. Number 9. Now, I can blather on about this so I can give you some examples. So, the graphs of f and g are given. Use them to evaluate each limit if it exists. If the limit does not exist, explain why. All right, so here's a couple graphs for you. Y equals f of x and y equals g of x. So, the limit of x approaches 2 of f of x plus g of x, that is the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. So, as x approaches 2, what is the function equal to? Oh, as it approaches, that's 2. Now, as g of x approaches 2, sorry, x is 2, g of x is approaching 0. It's a total of 2. All right? Now, point out a couple things here. It's the limit as x approaches 2 of f of x is 2, even though f of 2 is 1, a different number. It's the limit as you approach. Now, so here, let's look at the next one. Limit of f of x, sorry, as x approaches 1 of f of x plus g of x, or the limit, sorry, we rewrite it as the limit as x approaches 1 of g of x. So let's go here. When f of x is approaching 1, that is, x is 1, f of x is approaching 1. Now, what happens with g of x as we approach 1? Well, coming this way, that's 1. Coming from the other side, it's approaching 2. So what is it? 1 or 2? Well, here we get picky. It doesn't exist. these two different numbers, we can't choose one. So technically it does not exist. So this doesn't exist. We cannot calculate the limit as x approaches 1 of f of x plus g of x. Okay? Now, I'm going to pause here. I want you to think about that. Don't want the video getting too long. Then we're going to come back and do the rest of these limits, all right? Any questions, shoot me an email. Otherwise, watch the video again, read the notes, and good luck. Good luck.